Good morning. Today we will discuss about one more concept called recursion. What is recursion? Recursion is the definition, the function which calls by itself. The function which call by itself is called recursion. What is a function is a self block of instructions that performs some specific task, that is function. If you calling the same function again and again, then it is said to be recursion. So what are the properties of recursion? The recursive function should complete after finite number of steps. It should not end endlessly, it should not execute. So for that you have to design a base case through which it has to terminate. The recursive function call should terminate and you have to come out from that. So that is important. The properties of recursion is it should terminate. The recursive function call should terminate or complete after finite number of steps. For that you have to design a base case. You have to design a base case, design a strategy or design a condition through which the recursive function call should terminate. To complete or terminate. You can both one and the same. Okay, this is the properties of recursion. I will take one example through which you will understand better. Okay, what is the concept? For example, I want to, uh, you know, print the message hello on the monitor 5 times. Okay, so this is a monitor. I want to print hello 5 times. So I have to design a function for that. Define print hello. The name of the function, I can give any name to that. It's a user defined print hello. Every function should have a name followed by pair of parentheses, colon. This is a keyword. Then you have a function definition. This is a function header. This is a keyword. Okay, here I am printing print hello. Now I am calling the same function print hello. So what happens here? The same function is called. Once this function, how it executes? So once it's colon, this is a function statement within the function body. Hello will be printed on the monitor. Hello will be printed on the monitor. Again you are calling the same function. Hello will be printed on the monitor. Again you are calling the same function. Hello will be printed on the monitor. You see the name of the calling function is same. Called function is print hello. Call both are same, right? So within the function definition, you are calling the same function. So this is calling the same function again and again is, but here you have not designed a base case. You have to, for example, I want to print 5 times. It's not possible here. It is endlessly keep on displaying the hello 24/7. The message is displayed on the monitor. For that, I want to print only 5 times. How that could be done? So for that, what you have to do? You have to design a base case. For example, 5 times means you have to. It may be 5, 10. It's a user-defined value. Any number that you have to read from the keyboard. For example, this is the execution I will start. Always execution starts from the main, right? In the main you are calling, okay? So you are reading one value, n is equal to int of input, enter n. The n is the how many times you want to do that. Okay, this n is a value, right? I am calling now the function print hello n. Very important. For example, n is 5. You are calling with n is 5. This value 5. Print hello. Here what you have to do? You are taking a function, takes input, process and gives output, right? So it takes input in the form of an argument n. The same 5 it takes that. Here you have to design a base case situation. Okay. What you have to do is if n is equal to 0, then you should not do anything. You have to return else. You have to print hello first time. Then what happens? You should call same function print hello with not n minus 1 value. So I'll be explaining how it works. N is 5. You read the value from the keyboard, you give the value 5 n, and you are calling the function print hello with the value 5. 5 will be transferred to n. 5 is equal to 0 false. This will not be executed, else print hello. Hello will be displayed on the monitor. Now you are calling the same function print hello. Now n value is earlier 5. You are calling it 5 minus 1. Now it becomes 4. Is 4 is equal to 0? False. Print hello. Hello will be printed. Now you are calling the same function 4 minus 1, 3. 3 is equal to 0? False. Hello will be printed. Is it not? Now 3 minus 1, 2. 2 is equal to 0? False. Print hello will be printed. Now 2 minus 1. 1 is equal to 0? False. The value of 5 becomes 1 now. 1 becomes 0. Right? That is the situation. You have to think of designing a logic through which you should exit from the recursive function call. Okay? Recursive function definition. So 1 is equal to 0. 1 minus 1, 0. 0 is equal to 0. 1, again it will be displayed. 1 minus 1, 0. 0 is equal to 0. False. You are not doing anything. So you are returning from here. So 1 it is 5. It prints 5. 5 minus 1, 4. It prints at 4. 3. It prints at 2. Prints at 1. 3. So 5 times. For example, if I want to print 10 times, here n is 10. 10 is equal to 0 false. 10 minus 1, 9, 8, 7, 6, 5. Finally it goes to. So depending upon the nature of the problem, you have to design a base case through which you have to come out from the recursive function call. So this is the definition. We'll discuss on a classic example factorial through which you will understand better how the function calls, how all the function calls are executed in the RAM in the separate memory called stack. All forward calls are pushed onto the stack, and then once the base case situation is reached, all function calls are popped from the stack in the reverse order where the execution was started, and our job is done. Okay. Thank you. I hope you have understood the concept of the recursion, right? So we'll discuss factorial problem, then you will understand better. Thank you very much.